Hi guys, welcome back to day 9. Today we have the question called valiant perfect square. In this question, the given one number, we return the it is perfect square true. If did not perfect square, we return the false. So first of all, what is perfect square? First, perfect square is the if they given one number, we square root of that number, it get the correct int value, not float value. That is a perfect square. If we get int value, it is returns true, it not false. So here we did not have one condition, like we did not use any inbuilt functions, that is sqrt in Python, mat.power in Java. So this is the condition we have today. So if you did not get the answer, I will explain. Coming to solution of the question, it is very simple, and we are using with the help of binary search. Suppose they given n equal to 16. In binary search, we return 1 to 16, and we have two pointers. Suppose we have start point with 0th index and end point with n minus 1 index, and we find out the mid value. If the mid into mid value is greater than or equal to 16, we move the start pointer to mid value. Is less than or equal to 16, we move the end pointer to mid value, and if it is equal to 16, we return the mid value. So suppose here I return, one second, suppose here I return mid equal to, suppose for first iteration, start pointer is 1 and end pointer is 16. So mid value is 1 plus 16 by 2, that is 17 by 2. 17 by 2 is 8. Int value, it come 8.5 by we taken is here int value 8. And here 8 into 8 is equal to 64. So here m into m equal to 64. Here 64 is greater than or equal to 16. So we have three conditions, no? M into m equal to n, m into m is greater than n, m into m is less than n. Here m into m is greater than or equal to n. So here we move the end pointer to 7th value, that is mid minus 1 value. So I am erasing, and now end value is 7th position. So again we check the mid value. Now mid value is became mid equal to 1 plus 7 by 2, that is 8 by 2, that is 4. Here mid value is 4, and here mid into mid value, we want mid into mid value, no? Mid into mid equal to 4 into 4, 16. So here coming 16, and we have n value is also 16. So 16 equal to 16, we just return the mid value. So it return the mid value, and we have the mid value, that is we return the mid value, that means n is perfect square, we return true. So here return true. Now we take the not perfect square number and check with our logic, it is works or not. So suppose I take an n equal to 15, it is not perfect square. We check our logic with, so it work or not. Suppose I given 1 to 15 numbers, and we have two pointers, no? Two pointers. One is 0th index point and end point is last index. And we find out the mid value of these points. What is the mid value now? Mid value is mid equal to 1 plus 15 by 2, that is 16 by 2, 8. Now we check the condition, like mid into mid equal to 64, mid into mid is greater than or equal to n value, that is 15. So if it is, this is the condition we have. So we move the end pointer to mid -1 position, and this is the mid value we have 8. 7th position we move the end point. Hope everyone is understand. And now we have another elements, and we have another mid value. So we have another mid value. 1 second. Now mid value is equal to 1 plus 7/2. That is 8/2. Mid equal to 4. 8/2 is 4. Now we check the condition like mid into mid. What is mid into mid? It is 16. Now 16 is greater than or equal to 15. So again we move the is greater than condition. So again we move the end pointer to mid -1 position. That is mid is 4. Third position we move the third position. Now again we check the mid value. Now what is mid value? Mid equal to 1 plus 3/2. That is 4/2. That is 2. Mid is 2. What is mid into mid? Mid into mid equal to 4. Now check the 4 is less than or equal to 15. So if we have less than condition, we move the start pointer. So we move the start pointer with mid +1 position. This is the mid +1 position here. Mid is 2 here, and 2 plus 1 position is 3. Now end pointer and start pointer is same position. Again we check the mid position now. So again we check this one. Again we check this one. Now mid equal to, so both are same. No, 3 plus 3/2. That is 6/2 is 3. Now again mid is 3. Now check the mid into mid value. Mid into mid equal to 6 into 6, 9. Again 9 is less than or equal to 15. Again we move the start pointer to mid +1 position. Now we check that start pointer is greater than or equal to end point. Now it's break. So that is when the condition is break, that is not a perfect square. We given one while loop, that is always start pointer is less than or equal to end pointer. If it is condition is fails, it is not a perfect square. So our logic is correct. And this is the code. We already discussed that we have 2 pointers, start pointer and end pointer. We taken start pointer as 1, end pointer is num. Now we iterate up to start is less than or equal to end. Here we take the mid value. Here we have 3 conditions: mid into mid equal to num, mid into mid is greater than or equal to num, or mid into mid is less than or equal to num. When the mid equal to mid is num, we directly return the true. It is perfect square. Here mid is equal to mid is greater than or equal to m. We decrement the end pointer to mid -1 index. We already discussed in the logic video. And we already another condition, mid into mid is less than or equal to num. We start pointer to mid +1 position. If we did not, if the while loop is break, suppose start pointer is greater than end pointer, it is not a perfect square. So it directly return false. Coming to time complexity of the question, here we decreasing the n values by half, and again we decreasing the n values by half until we get the solution. So time complexity is, first we decreasing the n value by 2 and n value by 4 and another iteration, and n value by 16. That is it is in the form of n by 2 power k format. Suppose after k iterations, the size of the elements is 1, 2, so 2 power k equal to 1. Here n equal to 2 power k equal to log n base 2. So here k equal to n, that is time complexity is order of log n. That is the time complexity of this question. And coming to space complexity, it is, we did not take any arrays or any data structure, so if the time complexity order of 1.